on Blackboard. So let me show that. So let me share my screen. All right. So all you have to do is go to stats, well, Math 131. If you go to content, and then if you look right here, you'll see something called a T table. So you press that. All right. And that's the T table. So this is what we're going to be using today. So for a test for this weekend, you want to make sure that you have this available for you. So either print it out or you just have it downloaded. So that way when you're taking the test, you can reference it if you need to look up any answer. But this is how, well, this is what we're going to be using for test. All right. Any question in regard to this? All right. So let me go on to the note for chapter 16. I wish I could go and turn around the hands of time. Right. All right, everybody can see my screen right now? Where it's a chapter 16 confidence interval, the basic.
Yes.
So let's get to this. All right. So in chapter 16, what we're going to be doing a confidence interval. So the reason why we're doing a confidence interval, what we're trying to do, we're trying to make a conclusion about the population. So usually when we're using the confidence interval, we don't know what the population mean is, and we're trying to estimate what it could be. So instead of us trying to make an estimate where we say it's going to be exactly a number, we're not going to give a number. What we're going to do, we're going to give a range. So say, like, if the Dominican show, we want to find the average age of students. So if I wanted to find that, I could go to pretty much every single student in Dominguez Hill, and we could find the average age of students. But the thing is, we don't have to get every student in Dominguez Hill to get the average age of student. What we could do, we can actually just get an estimate of that. So to get the estimate of that, what we're going to be doing, we're going to create a confidence interval. So the confidence interval is going to give us a range of what it could be. So when I talk about a range, it should look something like this, where it should tell me, hey, the range of student for the average age of student in Dominguez Hill should be somewhere between 20 and we'll say 26. And this is how we're going to use the confidence interval, because the confidence interval is telling us, like, it could be anywhere between 20 to 26. So it could be possible that the average age of the student in Dominguez Hill could be 24, or it could be 25.
Oh, Mo!
And that's what the confidence interval is telling us. It is telling us the average age.
What's 5 plus 5 though?
All right, so let's. All right. So what the confidence interval is going to tell us, it will tell us all the possible answers that could be within that range. So when we find the confidence interval telling us it could be anywhere from 20 all the way to 26 of years of age. So that's what we're going to be doing for this chapter. Any question in regard to that idea so far?
Yeah, what's 5 plus 5?
Alrighty then. Let's remove. All right, so we got rid of those two, so hopefully it should be fine now. All right, so up here we go over the formula. So for the formula, we're gonna go over a point of estimate. The point of estimate is just our X bar. So kind of think about it, we don't know what the population mean, but we could estimate what the population mean is by taking an average of a sample. So we don't know what mu is, but we could find the sample mean, and the sample mean should kind of give us a good point of estimate of what it could possibly be. So when we talk about X bar, we're gonna call that the point of estimate because we don't know what population mean is, but we could just use the X bar to estimate what it to be. Right. Everybody good for the point of estimate? All right, so next is the standard error. So the standard error is just equal to sigma divided by square root of n. So if you kind of remember, oops, sorry about that. It is equal to sigma of X bar. So this is technically something we already did. Standard error is just sigma of X bar, which is just sigma divided by square root of n. The next thing what we're gonna do is how to find margin of error. So once you find standard error, to find margin of error, you're gonna get Z alpha divided by 2 and multiply by standard error. So in order to find this Z value, this is why we need the t-table. The t-table is gonna help us find what that value is equal to. Cool. So if you look at it, standard error, or SC, is equal to sigma divided by square root of n. So we get sigma divided by square root of n, and we multiply that by Z of alpha divided by 2. All right. So lastly, what we want to do, pretty much what we want to do, once we find the point of estimate, standard error, and margin of error, we're going to just put it into this where it says the point of estimate is plus or minus the margin of error. So the plus or minus means that we're going to have to do that operation twice. So we're going to have to do point of estimate minus margin of error, but we also have to do point of estimate plus margin of error. So we're going to say point of estimate minus the margin of error but we're also going to do point of estimate plus the margin of error. And mathematically speaking, it's just going to be X bar plus or minus Z times standard deviation and square root of n. And that's going to give us our confidence interval. Any question in regard to the formula? All right, so let's scroll on down. Reaction. All right. So for this problem, we're going to do the confidence interval. So for this one, says for a simple random sample of 16 Honda Accord, the mean gas mileage was 23 miles per the gallon. Assume the population standard deviation is 1.5 miles per the gallon. It is known the distribution of 2005 Honda Accord is normally distributed. So before I even go to A, B, C, and D, I'm gonna just first go ahead and just label everything. So the first thing they give me is 16, which is my n. So we say n is equal to 16. The next thing they give me, they say the mean gas mileage was 23 miles per the gallon. So we'll say X bar is equal to 23. Lastly, if you look at it, it says the population standard deviation is 1.5 mile per the gallon. So we'll put sigma is equal to 1.5. So like before you even get started with the problem, you kind of want to go ahead and just label everything. So that way, once you're actually doing the problem, it actually make it a lot easier to put it, because now we already have everything labeled. So we could easily just input it into the formula. All right, but any question in regard to n, x bar, or sigma? Okay, so let's do part A. So part A said, what will be the best point of estimate for the population mean mile per the gallon for 2005 Honda Accord? So keyword here is point of estimate. Point of estimate, all they're referring to is X bar. So are you saying if I don't know what the population mean is, I could use the sample mean to estimate what the population mean should be? Because if you kind of remember, a sample mean is should kind of give us a good indication of what the population mean should be, because the sample mean should be pretty close to the population mean. It might not be exactly correct. Well, it most likely not going to be exactly correct, but it should be close to 23 mile per the gallon. All right. Any question in regard to how I got X bar is equal to 23? All right. So let's do B. So if you look at B, it says find the margin of error for a 95% confidence level and explain what it represents. So for this one, we want to find the margin of error. And they tell us we have a 95% confidence level. So that's important. So the margin of error, the formula for margin of error, we'll put ME for margin of error, is equal to Z alpha divided by 2 multiply by sigma divided by square root of n. All right. So right now what I'm going to go ahead and do, I'm going to go ahead and find what this value is equal to. So to figure out what that value is equal to, that's where the t-table is going to come into play. So for the t-table, we only need one information. We just need to know what the confidence level is. So for the confidence level, we know it's 95%. So right now what I'm going to go ahead and do, I'm going to go ahead and just switch over to the t-table. So for the t-table, pretty much you can just ignore the top. The only thing you're going to use the last 3 rows. So you're only going to focus on this. So we're only going to focus on this portion over here. So if you look right here, it says confidence level. If you look at the row above, it has different confidence levels. So have confidence level of 0%, 50%, 60%, 70%, 80%, 90%, 95%. So this is where the confidence level that's given to you is important, because you just want to find which confidence level was given to you. So in our case, we had a confidence level of 95%. So if you look, what's right on top of 95% is 1.960. And that will be my my Z alpha divided by 2. So we'll say Z alpha divided by 2 is equal to 1.960. And that's how you find Z alpha divided by 2. Like you don't have to do anything else. That's your answer for Z alpha divided by 2. Any question on how to find Z alpha divided by 2?
Yeah, I'm kind of confused on that.
Which part are you confused about, Ness?
Kind of just like how you're, how you got that number, and what that Z that little thing above the other Z means.
You're talking about this one right here?
Yeah, that one.
Pretty much for this, just ignore this.
Okay.
That's not gonna make anything to your problem. The only thing I want you to focus on the confidence level.
Okay.
So for this one, your confidence level is 95%.
Uh-huh.
So to get the Z value for that 95%, you look at what the numbers on top of it. So the number on top of it is 1.96. So that's your answer.
Okay. And
So
then you have to multiply that?
no. Well,
Oh,
yeah,
okay.
you're gonna multiply a little bit later on, but
Oh,
that's
okay.
your answer for Z value.
All right, thank you.
Yeah. So say if we have a confidence level, let's say 99%. So if I have a confidence level of 99%, what will be the Z alpha divided by 2 for this value? And if you want, you can put it in the chat. So what would be the Z value for this one if we want a 99% confidence level? Yeah, good. Thank you, Karen. So for this one, it will be 2.576. Okay, if you look at it, here go 99%. If you look right here, you see how it says Z value? You select that row. So that means we select the 2.576. And that's it. All right, everybody good?
Can you explain that one more time? I could not follow.
Okay. Here, let me start over. Were you able to follow with the 95% or just the 99%?
I was able to follow with the 95.
Okay. So pretty much here go 99%. So you get the number right above it because if you look at the row right above it is the Z value. So since 2.576 is right above 99%, that's the number that you use. Same thing with like 95%. You go 95% and then we use the number right above it, which is the 1.96. All right. Any other questions? All right, sweet. So let me go ahead and transition over back to my notes. Well, actually, I am in my notes. All right. So let's go back to chapter 16. So now I know this value over here is equal to 1.96. Now what I want to do, I want to multiply by standard deviation, where standard deviation is 1.5. And you want to divide this by square root of n, where square root of n is square root of 16. All right. So if you kind of notice, for z alpha divided by 2, you replace that with the 1.96. And then you just multiply by standard deviation divided by square root of n. Right. Everybody good with how I got 1.96 multiplied by 1.5 divided by square root of 16? All right, so what I'm going to go ahead and do, I'm going to go ahead and multiply this out. So say 1.96 multiplied by 1.5 divided by square root of 16. And you get 0.735. So that's our margin of error. So the margin of error is telling us how much off we could be from the point of estimate. So it's telling us we could be 0.735 miles away from the point of estimate and still be considered correct. Because as long as our mean or our population mean is between the 23 mile per the gannett and between it by 0.735, we should still be considered correct. But that's it for B. Any question in regard to B?
How did you get the 0.735 again? I'm sorry, I zoned out.
You just multiply this out. So you just have to just do this in your calculator.
Okay, okay. Thank you.
Yep. All right. Any other question in regard to part B? All right, let's do part C. So if you look at part C, it says constructing 95% confidence interval for the mean gas mileage of a 2005 Honda Accord and interpret it. So what we want to do, we just want to finish it off. So we want to construct the confidence interval. So that means we want to get the point of estimate. And we want to add and subtract it to the margin of error. So for this one, if you kind of remember, we already found both of these. So we found the point of estimate to be 23 mile per decana. We added and subtracted to the margin of error, which we just found to be 0.735. So the 23 come from part A, the 0.735 come from part B. Any question in regard to those so far, what I have in blue? Correct. So if you look at the chat, Brando asks, will the point of estimate always be the mean? And the answer for that will be yes. It will always be the sample mean. All right. Any questions so far? Okay, so I'm gonna do 23 minus 0.735. So we'll say, so this is, you do 23 minus 0.735. You also do 23 plus 0.735. So you go 23 minus 0.735. And you get 22.265. Now you want to do the addition part. The addition part, if you add them, you get 23.735. And that's how you find the confidence interval. Any question in regard to how I get the confidence interval?
So just to make it clear, you just subtracted and added, and then those are the results under it, right?
Correct.
Okay. Okay. Thank you.
Yeah, you're welcome. All right, guys. All right, so I think we're gonna do the interpretation. So we're gonna do the interpretation of what did this represent? Because what the confidence interval is telling us, it's telling us all the possible value that our population mean could be. So it's telling us it could be anywhere from 22.265 all the way to 23.735 based off of this confidence interval. So I'm telling you, our population mean should be somewhere in between this with a 95% confidence level. So that's what we're gonna write. So the first thing what we wanna write, we wanna say how confident we are. So we wanna say we are 95% confident. So that's the first thing you want to say. You want to say, what is your confidence level? So it could be a 95% confidence level. It could be 80% confident level. It depends what confidence level you find the confidence interval for. The next thing what you want to write is what does the mean represent? So you don't want to say the mean. You want to say what does this mean represent in the context of the problem. So for this one, the mean represent the mile per decana a car get. So we're gonna say we are 95% confident that the population mean is, so the population mean of a 2005 Honda Accord MPG. MPG stands for mile per decana. So if you don't know what MPG stands for, it just stands for mile per Ghana. So we're gonna say we are 95% confident that the population mean of a 2005 Honda Accord MPG, which is the mile per Ghana. And then what you want to do, you want to put what is the confidence interval that you found. So we'll say the MPG is between, and then you put the confidence interval. So the confidence interval was 22.265 and 23.735. Let's see if I can do this a little bit nicer. All right, hopefully you can see that, but that's our answer for part C. All right, any question in regard to how we got part C for the confidence interval or either the interpretation? Okay, so let's do part D. So for part D, it says based on the confidence interval found in part C, is it likely that the mean gas mileage of a 2005 Honda Accord is 15? So it's saying using this confidence interval that we just found, is that confidence interval telling us, is it likely that 15 mile per Ghana is the true population mean? So what do you think? So if the confidence interval telling you the population mean should be between 22.265 and 23.735, and we're trying to figure out, is 15 a possibility based off of the confidence interval? Like, will we say it's a possibility?
I don't think so.
Cool. So we'll say no. There we go. All right. Well, why no?
Because it's not between 22.265 and 23.735.
Perfect. So we'll say no because 15 is not between 22.265 and 23.735. And that's your final answer for part D. Any question in regard to part D? Sweet. All right, so up next what I'm gonna do, I'm gonna show you how to get the confidence interval using ClassCalc. I'm also gonna show you how to get the confidence interval using your TI-84. So first I'm gonna do ClassCalc, then we'll do the TI-83. So if you have the if you have the ClassCalc, have that handy right now. All right, so let me erase this. All right. All right, so for ClassCalc, always make sure that you are in graphing mode. Because if you're not in graphing mode, you're not going to be able to do it. So first, make sure you're in graphing mode. Then what you want to do, you want to hit the stats button. And then if you look all the way over here where it says test, you want to do a test. All right, so that's where you should be right now. So if you look at the first row, it says Z test. It says 1 prop Z test. It says 2 prop Z test, 2 sample Z test, and then Z INT. You actually want to use Z INT. INT stand for interval. So we want to do the Z interval. Everybody good on how to find the Z interval? Okay. So if you look at it, it gives you 2 options. It gives you the option to choose stats or data. In our case, since everything is given to us, we're going to use stats. If the information is not given to us, that's when you want to use data. So we're going to choose stats, and we're going to enter the information. So the first thing you're going to do, enter standard deviation. So standard deviation, this problem, what was standard deviation equal to?
$1.5.
Perfect, 1.5. 0.5. Then you want to put what is x bar equal to. X bar is equal to 23. Then you want to put what n is equal to. N is equal to 16. Lastly, you want to put the confidence level. So for this one, the confidence level, you have to put it at the decimal. So if you put 95, it's going to give you, well, it could say something is wrong. So you do want to put 0.95. All right. So if you look at it, once you enter all of that information, it gives you a confidence interval on the bottom, and we're done. Any question in regard to how I enter anything?
No.
All right. So up next, what I'm going to go ahead and do is switch it over to the TI-84. So if you have a TI-84, this is your time to follow along. So pretty much first thing you want to go ahead and do is hit the stats button. So the stats button, once you hit the stats button, you should be in this screen where it says edit, calc, and test. So you're also going to go over where it says test. So just move it over to the right 2 times, and you're in test. So what we're looking for something that says Z interval. So if you look all the way down in part 7, it says Z interval. So you can actually just either go all the way down, select it, or if you actually hit the number 7, it will select it for you. So if you look at it, it gives you the same option. It asks you, is this a data or is this a stats? So data means that you're gonna give it the raw data. Stats mean you already know the mean, the standard deviation, and the confidence level. So since I already know all of that information, we're gonna choose stats. So for the mean, we're gonna, well, sorry, for the standard deviation is 1.5. My mean is 23, n is 16, and our confidence level was 95%. In your case scenario for TI-8384, it doesn't matter if you put 0.95 or 95, it will still give you the same answer. Like I'll put 95, go to calculate, and we get the same answer. So that's how you find the confidence interval using the TI-84. Any question for the TI-84? All right, so what I'm gonna go ahead and do, I'm gonna go ahead and switch back to my notes, and we're gonna go over that. All right. So let's go ahead and do the next one. All right. So for the next data set, what we want to do is that the following data represent the age and week at which baby first crawl based on a survey of 12 mothers conducted by Essential Baby. All right, so we want to find out like how long does it take a baby to first crawl, and this is in weeks. So we collect the data set. So we collect the data set of 52 week, 30 week, 44 week, 35, so on and so forth. So let's do part A. So it says use the information from the sample to give the best point of estimate of the population parameter. So for this one, we want to find the population parameter of mu. But the thing is, we only have a sample. So if I want to find the point of estimate, what do I find if I want to find something that estimates the population mean? So what would my point of estimate be? I'll give you a hint. It starts with an X. All right, no takers, I guess. All right, so this is X bar. It's the same thing. Your point of estimate is still point of estimate. Point of estimate will always be X bar. So what we have to do, we have to find the sample mean. So what we have to do, we have to get all of these numbers, add them all up. Once we add them all up, just divide it by however many numbers we have. So you're gonna find the mean for this data set right now. So what I want you to do, take a minute and find the mean of that data set. Yeah, cool. So 38.25. And that's it. Thanks, Vanessa. In a minute, it stopped sharing my information, so let me redo that. Okay. So we should get 38.25. So that's our point of estimate. So for part B, it says assume the population standard deviation is 10 weak and find the standard deviation. Oh, sorry, find the standard error. So standard error, if you remember, is equal to sigma divided by square root of n. So for this one, they tell us sigma is equal to 10. They tell us sample size is equal to 12. And remember, sample size is how many data sets do we have? So if you count how many numbers do we have, is 12. So that's where the 12 come from. It come from how many babies did we record data set from. So I'm gonna do 10 divided by square root of 12. So I'll say 10 divided by square root of 12. And you get 2.89. And that's it for part B. Any question in regard to part B? All right, so let's do part C. So if you look at part C asks construct a 95% confidence interval estimate for the mean age at which a baby first crawl. Assume the data come from a normal distribution. So for this one, we just want to do a confidence interval. What are the confidence levels that we want to use for this one?
95.
Yeah, 95, perfect. So we want 95%. And we'll put CL for confidence level just to make it easier. All right. So what we're gonna go ahead and do, we're gonna go ahead and do this in class calc. We're also gonna go and do this in the TI-83. And the important thing for this one, if you look at it, we actually have data. So in this case, instead of using the stats option, we're gonna use data option. So I'm first gonna do this with the TI-84. So let me share my TI-84 with you. So first, turn it on. So the first thing you want to go ahead and do is go to stats, go to edit, And if you look right here, you want to enter all of the number sets. So you want to do 52, then you want to enter 30, then you want to enter 44, 35, 47, 37, 56, 26, 39, 26, 39, and 28. So you just want to enter all of that number. So I'll give you a minute in case, for that way you can enter those number sets. All right. So hopefully you already enter all of the numbers. Did anybody still need more time to enter the numbers? All righty. So what I want to go ahead and do, we're going to go ahead and hit the stats button again. You're going to go over here where it says tests. And then we're going to go to Z interval again. So in our case, we don't have stats anymore. We have data because pretty much that's what we enter in L1. We entered the data. So you want to select data. So now the only information I'm going to ask you for is for sigma, where do you put the data and what is our confidence level? So for sigma, sigma is not equal to 10. 10. For the list, that's where you tell it where the data is. Since I put mine in L1, I leave it as L1. For my confidence level is still a 95% confidence level, so I'll just leave it as this, and you go to calculate. So if you look at it, the answer that I get is 32.592, and I get 43.908. And that's how you do it with the TI-83 when you have data. Any question for the TI-83 or 84, sorry? Okay, so up next we're gonna do this with class calc. All right, so everybody should be able to see my class calc. So for class calc, we're gonna go to stats. We're gonna go to tests, and we're gonna do a Z interval. So first thing you want to do, you want to change it from stats to data. So I'm going to select data. So if you look at it, the first thing it asks for, it asks for what is the standard deviation of the population. So the standard deviation of the population is 10. The next thing you're going to ask for is going to ask for, if you see it has capital L, that means the list. So I want you to enter all of the data sets there. So my data set will put 52, then you put a comma, you put 30, comma, 44, comma, 35, comma, 47, comma, 37, comma, 56, comma, 26, comma, 39, comma, 26, comma, and 39, 28, 39, and then finally 28. All right, so that's my list. So the last thing I want to do is put my confidence level. So confidence level is 0.95. And if you look at it, you get exactly the same answer that we got with the TI-83 or 84. Any question in regard to the steps I took for the class calc? All right, so I'm going to switch over back to my notes. Yeah. So if you look at it, that's the answer I gave for part C. Everybody good for part C? All right. So what I want you to do, I want you to practice on this next problem. So take a minute and try and do this one. Also, what I want you to do, so you could do this in ClassCalc, but if you can, try finding the 95% confidence interval. I want you to find the Z value. So try finding that. So I'll be right back. So in the meantime, you try working on that. So hopefully you were able to find n is equal to 15, sigma is equal to 270, x bar is equal to 1,230. Was anybody able to find the Z value?
Professor, I actually have a question. The answer for the last question that we did was just what was it again? I'm sorry. Okay, so it was that. Okay, give me a second. Okay, thank you. Also, would it be 2.576 for the Z thing?
What was that again, Mallory? Kind of cut off a little bit.
For the Z, is it gonna be 2.576?
Yeah, good.
Okay.
2.576. All right, so I'm gonna give you the answer for the confidence interval. So for the answer that you should have gotten when you done the Z interval on ClassCalc or on the TI-84, you should have gotten 1,050.4, and you should have gotten 1,409.6. Right. So that's the answer. Hopefully you should have gotten it. Any question in regard to the last problem? Very sweet. All right. So that's it in regard to how to find them mathematically. So up next is you're going to kind of hopefully reinforce the concept of the confidence interval. So up next is just going to be a simulation. So we're going to go over this simulation. No, I use my hand. All right. So right now, everybody should hopefully be able to see a screen which says simulating confidence interval. So we're kind of gonna go over different confidence interval, and you'll see how does the confidence interval, like what would happen with the range of the confidence interval if I start switching the confidence level. Like would the confidence interval get wider, or would it get narrower or smaller? So that's what we're kind of gonna go ahead and do. All right, so for this one, I put that the population mean is 25.6. So what's gonna happen, we're gonna get a confidence interval. If the confidence interval have 25.6 in between the two values you give me, it's gonna give me a green band or a green line. If the 25.6 is not between the two numbers, then it's gonna be red. So if it's green, that means it will actually able to capture the population mean. If it's red, it didn't capture the population mean. So we're gonna go ahead and do our first sample. Oh, let's do it right here. Actually, let me change one thing. Let me change the sample size to 40. Let's do that again. Actually, let's change that to 20. All right. So everybody see a black vertical line that says 25.6 and then a green band. So I don't know if you could tell the number, but if you look at the number of the green band, it says 21.692 all the way to 30.457. So the reason in green, because 25.6 fall in between those two numbers. So that means this confidence interval was actually able to get me the correct range of the population mean. So telling me it was able to do a good job in getting the population mean because it was able to capture it in between those two intervals. So what I'm gonna go ahead and do right now, I'm gonna change the confidence level. So we're gonna change the confidence level and see how did that affect it. So say if I go from a confidence level of 95% and say if I change it to 50%. So if I go from 95% to 50%, that means I'm less confident. If I'm less confident, how do you think that's gonna affect this interval? Do you think it's gonna make it wider or should it make it narrower? So wider or narrower? Well, if you kind of think about it, when are we more confident? Are we more confident on a wider interval, or are we less, or are we more confident if it's narrower? Because if it's narrower, that means you have less option. If it's wider, good. So you're more confident when it's wider. So if I make it smaller, so if I say I'm less confident, instead of it getting wider, it should get narrower. And let's see that into play. Keep on hitting the wrong. So if you look at it, it indeed got smaller. And if you look at it now, it became red. And it became red because it didn't capture the true population mean. Because it's saying it should be between 22.104 and 25.121. So it didn't capture 25.6. All right. So when we do the confidence level, or when we do a confidence interval, the confidence interval is not meant to be done only one time. It's meant to be done multiple times. Because what the confidence level is telling me, the confidence level is telling me if I repeat this interval, or if I keep on doing confidence interval, it's telling me how many times would it be correct, how many times would it be incorrect. So it's telling me like how confident we should be in the method of the confidence interval. So if it says confidence level 95%, it's telling us 95% of the time it should be correct, and then 5% of the time it should be incorrect. So if I do this 100 times, which I'm gonna do in a bit, it's gonna tell me that since we have a 95% confidence level, we should see 95 green line, and we should see 5 red line, But you kind of remember, since this is a probability, it's not a guarantee. So we might get like 6 red line and 94 green line. So it's not exactly 95%, but it should be close to 95%. So let's go ahead and see that. Very good. So if you look at it, you get 1, 2, 3, 4 red, and you get 96 green. So that means it was correct 96% of the time. If you actually look right here where it says interval containing mu, it says 96 out of 100, which is 96%. So this is what the confidence level is kind of also telling us. It's telling us if I repeat this experiment or this method many times, it's telling me how many times would it contain the population mean, how many times would it not contain the population mean. Any question in regard to this so far? All right. So what we also want to kind of go ahead and see, we kind of want to see how does the end sample size, how would that affect it? So right now I had a sample size of 20. So say if I go from a sample size of 20, if I go to sample size of 1. If I'm doing a sample size of 1, a sample size of 1 is less precise because that just means I'm taking one sample. So it's not a very good estimation. So for this one, anytime you get a smaller sample size, you're actually gonna get what you call it, you're gonna get a wider band. So if I go ahead and do this, you're gonna notice all of these confidence intervals are gonna become much wider, which they did. Because kind of think about it, the more data set you have, the more precise it should be. The less data set you have, well, the less precise it should be. So this is telling me, hey, if I have a sample size of 1, it could be less precise because like we only have one sample. But say if I increase this to a sample size of 100, a sample size of 100 will be more precise. So we should be getting a narrower confidence interval, which you notice that. So you kind of know if you increase the sample size, what's going to happen, you're going to get a smaller confidence interval. If you decrease the sample size, you're going to get a wider interval. And that's it for that. Any question in regard to the simulation? All right, so let me go back to the notes. All right, so we're pretty much all done for chapter 16. So what's gonna happen on Thursday, pretty much you're gonna be a review. So if you still haven't, let me see, sure. So if you still haven't, what I want you to do is do the study guide on Blackboard. So to do the study guide on Blackboard, all you have to do, click on content. And if you look right here, it says test 3 study guide. And for this one, you could take it as many times as you want. So I want you to take the test. And then what I want you to do is just get questions that you have on the test that you got wrong and you don't know why you got wrong. For that way, we could go over this during the class period. So you try doing it, and it should give you the correct answer. All right, so you try doing the study guide, and that way on Thursday, you can ask questions in regard to the study guide. Any question in regard to that?
Wait, so Thursday we won't be having like a lecture? Or...
No, Thursday is going to be review. Because we're all done with all of the chapters. We're all done with all of the chapter for test number. Which test is this? Test number 2? No, test number 3, sorry.
When is exam number 3?
For exam number 3, since we finished that up today, well, since we finished up all the thing today, I'm going to leave it for over the weekend. Well, I'm going to leave it for over the weekend all the way to Tuesday. So you should have enough time to be able to do the exam.
And it's just gonna be chapter 14 through 16, right? Or which ones?
Here, let me just pull up the syllabus so I can give you the correct one. All right, so for for test number 3, the chapter you're gonna be tested on is 12 all the way through 16.
Did you say 12 all the way through 16?
Correct.
And there's gonna be 23 questions, like in the study guide.
Here, let me check that. I
Are
don't
we
think
able to
they're-
leave now?
What was that?
Are we able to leave now? Because I have somewhere to be. I'm sorry.
Yeah, no, like we're pretty much all done with the class.
Okay, bye.
Bye-bye. For the test will have 19 questions.
Oh, okay.
Yeah.
All right, thank you.
Yeah, you're welcome. Any other questions? Alright, so just remember, do try to take the study guide exam, preferably before Thursday, so that way you can have question about anything that was on the study guide. And yeah, so you just have this. So for Thursday, whichever question you want me to go over, I'll go over those questions. So that way you know how to get the correct answer for those questions. But the test, open it up on. Well, I could just open it up on Friday and then I'll close it all the way till Tuesday. So that way you should have a good enough time period to take it. Hopefully during somewhere in that time period. And I'll give you 2 hours for that test. So hopefully that should be enough time. All right, any other questions? Okay, so what I'm gonna go ahead and do, I'm gonna end the meeting right now, and I'm gonna reopen it. So that way, if you do have any questions, I have office hour from whenever I show back up, all the way to 12:15. So that way you can ask any question. All right, have a good day, guys, and I'll see you on Thursday. You too, Brian.